Hello again, Chemistry, Earth, and Space Science. We're in Unit 4. We're still on lesson number 2, the second video of this series, and we're going to be dealing with two of the four types of main reactions. That's synthesis and decomposition. So synthesis reactions. Let me get rid of this precursor. Driving me a little crazy. Okay, synthesis reactions. A synthesis reaction happens when two or more substances combine, usually they're going to be elements, to form a compound. You have two reactants and one product. And you can tell this isn't synthesis because you've only got the one product. So it's A plus B gives you AB. Example might be potassium plus chlorine to make the potassium chloride. Here's potassium as a metal, shiny metal. Here's chlorine gas as a cloudy yellow cloud. We initiate the reaction by adding a little bit of heat, maybe with a spark or something along those lines, and we get this white powdery substance which is potassium chloride. So what would happen if we took magnesium and reacted with chlorine? Well, in order to write a reaction for synthesis, we're going to first write the reactants symbols themselves. So that would be Mg plus a Cl, and don't forget it is a Brinkelhoff, so it's Cl2, yields, and now we bring it together. The second part is make sure you write the charges on the atoms. Okay, when I know they're going to be in the compound, so I'm going to make magnesium chloride. I combine them to make the new compound, and then I do my crisscross as necessary. So I get a magnesium plus chlorine gives you magnesium chloride. Okay, next type is the decomposition. Oh, at that point, you should be able to knock out the synthesis reactions page of the homework. Next one was the decomposition. It has a couple funny little nuances in here. So for decompositions, you have one reactant to make two products. We know that. And for our purposes, we're going to mostly look at it from it's going to decompose into its elements. Okay, so when we have this decompose, we're going to make the elements. So for instance, down here we got mercury 2 oxide reacting to make mercury and oxygen. And again, you're going to see a whole lot of elements here, and some of the more common elements are those Brinkelhoffs, so don't forget those subscripts of 2. So here's one. You got this, that's mercury oxide. It's a brownish, almost rust color, but it's like more of an orangish rush. And you heat it up over fire, over a flame, really, really hot, and it will break into two parts. It will break into the mercury liquid will be left behind, and oxygen gas will rise out of that mess. So there's two subtle, odd decomposition exceptions. One revolves around carbonates and one revolves around chlorates. Carbonates and chlorates both decompose not necessarily into its elements, but into smaller compounds in a very organized way. So let's look at both of them. So what's going to happen is a carbonate, if you have a metal carbonate, a sodium carbonate, a lead carbonate, an iron carbonate, whatever it happens to be, has a carbonate in there, it's going to break into carbon dioxide, and whatever the metal is going to take and link up with the oxygen. Now the element is going to maintain, the metal is going to maintain its charge. In doing so you'll be able to know how many oxygens are attached to it, but you're going to make carbon dioxide instead. And it kind of makes sense. If I have CO3 and I pull out carbon dioxide as one of the products, what's left behind is one oxygen, and then whatever the metal was, it was attached to the carbonate. So an example might be calcium carbonate. If I take calcium carbonate, CaCO3, I heat it up over a flame, I'm going to get carbon dioxide gas, but I'm also going to get calcium oxide. It would be CaO because calcium is +2, oxygen is -2. Chlorates decompose oddly also. Chlorates will decompose into oxygen gas, but then the metal is going to pair up with the chloride in the chlorate ion. So for instance, one might be aluminum chlorate. Aluminum chlorate would react Again, decomposing it over a heated flame, very, very hot to make it decompose. And what will be produced is oxygen and also the aluminum chloride itself. These are two oddballs. They're not quite the same as just breaking it into its elements. If you have a compound that has a carbonate or a compound that has a chloride in it, you want to consider doing those a little differently. So let's try some. So if I have lead oxide decomposing, what's it going to make? Well, you got lead 4 oxide, PbO2, going to decompose. Well, that's going to break down into its elements. So it's going to make lead, and it's going to make oxygen, but oxygen is a Brinkelhoff. So put a 2 in there. What about sodium carbonate decomposing? We said carbonates decompose to make carbon dioxide and the metal oxide. So if I have calcium sodium carbonate, one of my products is going to be carbon dioxide. And the other one is going to be the metal oxide. The metal with sodium with a +1 charge. Charge doesn't change. And oxygen is oxide with a -2 charge. So it's Na2O plus CO2. And the last example would be that chlorate. Sodium chlorate decomposing. Sodium chlorate, chlorates make oxygen and the metal chloride. So I take my sodium and my chlorate, I heat this sodium chlorate up. And when I do that, I'm going to make sodium chloride, the sodium, the +1 sodium ion with the chloride, and then oxygen. Now, in order to balance it, I need 2, 2, and 3 coefficients because oxygen is a diatomic element. So synthesis, pretty easy. Decomposition, mostly easy. You have to stay on top of paying attention to whether you have carbonate or a chlorate. So at that point, you should be able to do the second page, the next pages of the homework on decomposition reactions. I'm going to come back with another video on just single replacements.